So in compound interest, the biggest difference from simple interest and the compound interest is interest on interest, interest on interest. So you have interest of this year, the next year you get interest on interest. Following year you get interest on interest. So you get like interest forever. Okay, you get interest forever. All right, so what kind of accounts are compound interest? Anything you deal with this now these days. So you go to a bank, they give a compound interest. You borrow money, they charge compound interest. You have a student loan, compound interest. So you pay interest over interest. You have a car loan, compound interest. You pay interest over interest. Okay, so compound interest has interest over interest. So let's understand this scenario here. Let's understand this scenario here. And I want to compare the scenario of this compared to compound interest. Let's read this paragraph from here to here. Okay, who can read this for us? Let's see. Kaylee, do you mind to read this for us? In 1626 all the way down to 5.6 billion. Let's understand.
All right. In 1626, Peter Minowa convinced the Ratzinger Indians to sell him Manhattan for $24 if the American had put the $24 into a bank account at a 5% interest rate compound annually. By the year 2021, there would be well over $5.6 billion in the account. So how did the present value of Manhattan in 1626 attain a future value of over $5.6 billion in 2021? 395 years at 5% simple interest is A equals P in parentheses 1 plus RT equals 24 in parentheses 1 plus 0.05 times 395 equals $498 compared to over 5.6 billion.
Okay, so we want to wonder, it's a $24 worth sold whole island of Manhattan. Thank you, Caitlin. So there are two different accounts. Let's understand two different accounts. Okay, there are two different accounts. One account is a simple interest. Another account is a compound interest. Okay, another account is a compound interest. Okay, so let's see the difference between two accounts. It's already been computed in here. If the money $24 into bank for simple interest account, after 395 years, account balance is $498, not even $500. It's because this account get interest on $24. So first year interest on $24. Second year interest on $24. Remember, simple interest account, interest only on original amount. So 100 years after, still interest on $24. 200 years after, still interest on $24. You know what I mean? So you keep having interest on $24 only for 395 years. On the other hand, if the money deposited into compound interest account, first year, $24 interest, and then next year, the interest on first year. Okay, so interest on interest, 100 years after, interest on interest for 100 years. So the money become $5.6 billion. Can you compare about $500 to $5.6 billion? It cannot be comparable. Think about how expensive the Manhattan Island is now. So let's understand how powerful compound interest is. So let's look at this. Okay, so let's do math computation in here. Simple interest, A equal to P times 1 plus RT. That's what it is. Okay. And let's assign those numbers into letter parent, A, P, A, R, T, okay, P, A, R, N, T, parent. P, beginning amount, $24. A, I don't know what's future value. The rate, let's fix the rate as 5%. It's reasonable. T is 395 years. It's because 1626 and subtracted from 2021 of the current year, it's about 395 years. All right, so let's substitute A equal to 24, 1 plus 0.05 times 395. Okay, so how do you compute this into your calculator? As it's written here. So you type 24, open parentheses. Now on, you have to know how to use open parentheses and the close parentheses. So without having calculator like this, you don't have those parentheses keys. So make sure you're going to have one of these calculators. For this particular example, we only use the parentheses once, but later examples, we are going to use a parenthesis in one formula. We use 3 parentheses and things like that. So you have to have these types of keys. So right here, here's a parenthesis, here's a parenthesis. You see this case right here? Okay, parenthesis keys. So you just type 24, open parenthesis, 1 plus 0.05 times 395 and a close parenthesis, something like that. Okay, so 24. Can you see? You know,
For example, if I want to do 2 times 3 plus 5, if this is written down, I would write this parentheses right here, and I know that.
I'm sorry, who's talking here? The voice is broken. Who is talking? Okay, I don't know. Here, originally we have to do order of operation, but this computation, something like this, you can just do it in one step in calculator. This calculator automatically recognize order of operation. So just in one step, and then you entered, you should have 495, which is exactly what we just computed. So your balance after 395 years, it's $498. Now compound interest, the interest on interest. So I'm going to modify it from this formula. This is a simple interest, okay? Modify from this simple interest formula to rewrite it. So A equal to P times 1 plus RT. Okay, 1 plus RT. I want to remove this T, put that into exponent, okay? Put that into exponent. Okay, that's the only difference from simple interest to compound interest. So simple interest, you multiply time being. Compound interest, you put that power. It's because interest over interest, okay? So same thing, P-A-R-N-T, okay? So compound interest, okay, same thing, compound interest. That is $24. We do not know the future value, still 0.05 for 395 years. See that? At the same, exact same number that we substitute. The only difference from the simple interest compared to compound interest, it's the T goes inside of parentheses or go to exponent, okay? So exponent. Do you know how to use exponent? So those of you who have a calculator, that exponent key, you have to hit head like this type of key, okay? So you have to hit that power. Some of your calculator has x to the power y, another calculator y to the power x. Those extra key that you have to press before you hit that exponent, okay? You hit that exponent. So let's do it. A is 24, 1 plus 0.05 to the power 395. Okay, to the power 395. All right, every calculator is different, but you have to put the exponent. So let's do it in one step, okay? So 24, you type 24, open parentheses, 1 plus 0.05, close parentheses, okay? So this is what we have so far. Do you see it? This is what we have so far. Can you see the screen? Can you see my screen? Okay, hopefully.
How did we get the parentheses again? I'm sorry.
Don't you have a parenthesis key right here? You see that?
All right, thank you.
Okay. right above numbers right here. So this is a parenthesis right here. You see that parenthesis case? All right, and then you hit one of those power keys right here. Hit one of these power keys. You hit that. And then you have like that power. Do you see it? Power 395. Okay, enter. Then you have a bunch of numbers like this. Okay, let me write it. This is 5623210928. All right, like that. There's no that small. Okay, any question? How do you get this number? Okay, let's put the comma after 3 digits. So here's a comma, here's a comma, here's a comma. This is over $5.6 billion. Okay. Terry, let me look at your calculator. Can you put your calculator in the camera? Let me see, what kind of calculator do you have? Yeah, that also do. That also do. The only difference is the type of Italy's calculator, you have to put the multiplication here. Then you can do in one step. Okay, some calculator type 24 parentheses 1 plus 0.05, and then you hit the power and then 395. That's straightforward to do it. Another calculator, okay, you have to type 24, you have to hit the multiplication, and then you have open parentheses, this is not C, open parentheses, 1 plus 0.05, and then close parentheses, and then you hit the power 395. So here's the extra key that you have to put. Okay, it's a depend on what kind of calculator you have. If you have a calculator TI 30X2, this type of calculator, there's no multiplication. Okay, so you just type it into one step. Okay, any question? All right, now I want to go furthermore. Okay, so do you understand the idea of the compound interest? So compound interest is the interest on interest. Do you understand this? So as you see, the descendant of the Indian is smart enough. They put the money into compound account instead of simple account. Look at this. Do you understand this? Compound account instead of simple account. Now in a compound interest, I want to go one more step. That step is, this is account only get once a year interest. So end of December 31st, you get interest of 5%. End of December 31st, next year, you get interest on 5% of both the principal and the interest rate. Now, instead of having once a year, likewise, you have a savings account. Your statement comes every month. So my savings account comes every month. I have account with the Bank of America, and they do give the statement every month. And what happens is every month you get a little bit of interest. So I have a 5 cent last month, and this month I have 6 cents this month. They don't really give much of this. Maybe I don't have much money, but you get a little bit every month, right? So I want to add those things. So do you remember when we decide this assign the letter? When we decide assign the letter, I said always memorized parent, right? Parent. So in parent, what's the missing letter? It's N. Parent. Missing letter is N. So in a parent, so let me rewrite it. So parent, P-A-R-N-T, just the order, parent. Okay, so just keep in mind, we use the letter parent. P is still $24. A, I don't know. Rate 0.05, and T is equal to 395, and nothing changed. I just add an extra N here. So now we have to understand the meaning of N. Okay, so here's meaning of N. Suppose you get interest every month. Okay, suppose you get interest every month, like the Bank of America, every month, N equal to 12. If you get interest every day. Some people do every day, okay? Then this is equal to 365. Some people get interest every 3 months, so it's a 4 times a year. You know what I mean? So you can have all these numbers, or if you get interest every week, then I write it as 52. It's because it's a 52 weeks a year. So how do we define N then? Okay, how do we define N then? N is number of interest paid per year. That's N. Okay, let me repeat. N is number of interest paid per year. That's N. Okay, number of interest paid per year. So let's look at it. It says compounded monthly, meaning every month. That's what it means. Compounded monthly. Then I put N equal to 12. Okay. Now, if N equal to 12, how does this account balance affect? So N equal to 12, here is, you ready? N equal to 12. You divide this by 12 and you multiply this by 12. That's what it is, okay? You divide and multiply, so it's even out. Do you understand this? So if it's just a monthly, meaning every month, okay? So interest paid per year, you have a 12 times a year. Let's compute, okay? Let's compute. So it's here, you divide it by 12, you multiply by 12 right here. Okay, I want to erase this number. It's because we need to compute. Just keep in mind that was over 5.6 billion. So just remember this, okay? That was a 5.6 billion. And let's see how does our balance affect it, okay? So here is, so since it is a multiplication here, I want you to do that exponent first. So I want you to compute this part, exponent first. So 395 times 12, which is a 4740. Agree? Which is a 4740. So let's rewrite the formula. Okay, let's rewrite the formula. That is 24, 1 plus 0.05 over 12 to the power 4740. Okay, do we understand how we get 4,740? Okay, now you have a calculator. I give you a minute. Find the number. Find the number. Okay, so you have a calculator to find the number. And whoever has, please read from your screen so we can share.
I'll say I have it, but everybody.
You have it. Who has it? Kayla? Kayla has it?
Yeah.
So let's see. Kayla, can you read? It's a really big number. Can you read the number for us?
I got 8703768547.
Wow, like that. Okay. So let me give a comma every third. This is 8.7 billion. Okay, now let's understand this. Okay, let's understand this. Assume, I mean, I didn't change the percentage or any time or anything. The only difference I made it is instead of paid once a year, I get paid every month, right? So it's a monthly paid. All of a sudden, was a 5.6 billion. Now it's 8.7 billion. You just have extra $3 billion. No problem, I take it. Why it happens? Anyone know why? Why things happen like that? Okay. Not yet. Okay, let's do one more computation. Okay, so keep in mind, if we get paid every month, okay, if we get paid every month, we have 8.7 Okay, $8.7 billion. Okay, now I change this to. So instead of every month, what if I get interest every week? You do. So every Friday you get interest. It's possible. So what if your interest is every week? So there are 52 weeks. Okay, now I change this to over 52. Okay, I change this to 52. Okay, 52, 52. So let's erase this. Okay, so rewrite it. This is a 52 weeks. So it's a 52. Okay, let's multiply 395 times 52. You have 20540. Okay, and then you are writing exponent. Okay, 20540. Let's compute this. Okay, again, I'm asking. It's overflow. I have overflow. Kayla?
Yeah, I got 8, 9, 8, 2, 6, 8, 5, 4, 2, 4.
Maybe 2 point what?
8, 9, 8, 2, 6, 8, 5, 4, 2, 4.
Like that?
I'm sorry, I have a raspy voice. 8, 9, 8, 2, 6, 8, 5, 4, 2, 4.
8, 9, 8, 2, 6, 8, 5, 4, 2, 4.
Yes, that's what I have. Yeah.
So it is that what you have? Let's see.
Yes.
Oh, this is 52. Sorry. Eight, 9, 8, 2, 6, 8, 5, 4, 2, 4. This is 8.9 billion. Oh. Okay, you even
Professor, can you
Okay.
show us in the calculator again? Because I don't know how she got that.
okay, so you have do you have this
Please. What? Yes.
formula? So you type here. Okay, let's type it. 24. Okay. You type 24. Open parentheses. So you got parentheses right here. Right here. Open parentheses. 1 plus. So you type it in here. No, 1 here. 1. And then you have a plus. Where is it plus?
Yes.
0.05. So you just type it 0.05 over 52. Okay.
Mm-hmm.
And then you put the cross parentheses right here. You see the parentheses here, close parentheses. So close parentheses. So I have, this is my screen,
Okay.
screen to the power. This is the power. You see the power? And then
Yes.
20540. So 20540. And you entered. And then this is what Kayla has. And that's what
Oh, now I got it. Oh, okay. Yeah. All right.
okay. So this is 8.9 billion. No problem. You have extra $0.2 billion. I take it. Okay. It looks like it's a 0.2 billion is not much, but that's really millions of dollars, right? So what we just learned from here. As you see, okay, I want to move up here. As you see, if you get paid once a year, okay, it was roughly $5.6 billion. Okay. If you get paid at monthly, every month, it's roughly 8.7 billion. I don't know. Guys, remember this number? 8.7 billion. If it is weekly, roughly get 8.9 billion. So my assumption is if you get every day, daily, I think my number is higher than this number. Agree? Yeah, it's because it's a pattern, money gets higher. But why? Interest rate is not going up or down, it still remain as 5%. But why my account balance is jumped high like this? Anyone?
Because it's happening more often.
Yes, it's like Caitlin says, that's a power of a compounding. You get interest on interest. So if you get interest on every year, you only get interest every year, right? If you get interest every month, you get interest on interest, and then interest on interest. So you have interest on interest 12 times a year. If it's weekly, you have interest on every week. Guess what? You have interest on interest. You know what I mean? That's the power of compounding. So compound is interest on interest. You see that how powerful it is? So this is one like typical scenario. Put the money for 395 years, but we don't live 395 years like that. But this gives us an idea. We can be a millionaire if you start saving IRA account for your retirement account. You can be a millionaire. We will talk about this in a few minutes after. Okay, so do you understand the power of a compounding here? All right, so let's review of a power of a compounding. Okay, so do we understand the formula like this? Do you understand the formula like this? Okay, so let's have another example right here. So if we understand the formula like this, I want to go over the meaning of this. Okay, so let's make it big. Next page. All right, so we can do example next time here. Calculating amount for compound interest. Let me make it big. All right, paid more than once a year. We call the period of time between two interest payment is called compounding period. And what kind of a compounding periods we have? We have compounded annually if interest is paid once a year. See that? If interest is paid once a year, compounded annually. We only paid once a year. If compound interest paid twice a year, we call it semi-annually. If compound interest paid 4 times a year, we call it compounded quarterly. If compound interest paid every month, we call it compounded monthly. Do you understand this term? Okay, compounded monthly. So if it's compounded annually, then I know, okay, n equal to 1. Compounded semi-annually, n equal to 2. You get twice a year. Do you understand this? Every 6 months, twice a year. Compound interest quarterly, n equal to 4. Compound interest monthly, n equal to 12. Do you understand this? So n is a number of interest paid per year, okay? Number of interest paid per year. In general, if compound interest is n, okay, you see that at n times a year, we called n is compounding period per year. Compounding period per year. So here's a formula, the bottom of the page. Okay, if P dollars deposited into the rate R, okay, compounded interest paid n times a year, try to get A amount. This is the formula. Okay, so let me repeat this on the right side. Okay, just put this in here. We usually say A equal to P times 1 plus RT. Okay, let me show you how to modify this. 1 plus RT, this is a simple interest. You remove this T to the exponent, become compound interest. Okay, And then we have a compound period. Divide this number, multiply that number. Okay, that's what we did. That is the formula that we have right here. And how do I know which is which? We write it as parent, P, A, R, N, T, and we substitute all these guys. Do you understand this? We substitute all these guys. So let's practice. Compound interest per year, okay? Compound interest. Let's have an example. Okay. You deposit 7,500 in a savings account. It has rate of 6%. The interest rate is compounded monthly. How much money you have after 5 years? Now, how do I know which formula to use? Okay, so we have two formulas. Let me write it. A equal to P times 1 plus RT, and A equal to P times 1 plus R over N to the power NT. Which formula to use? Here is a magic word, compounded. If it is a simple, then you use a simple. If it's compounded, you use compounded. So I want to erase this. This is the right formula. That's how you decide. Do you understand this? That's how you decide. A equal to P times 1 plus R over N to the power NT. This is how you decide. Do you understand this? This is how you decide. There is a magic word, compounded. Okay, so I want to rewrite it. Compound formula, compound interest formula. So there are two things to do. A equal to P times 1 plus R over N to the power NT. That's the first thing we do. And we need to assign those numbers into the letters. So write it out, parent, P, A, R, N, T. Okay, write it out, parent. And then we assigned deposit, present value, 6%, 0.06. Compounded monthly, 12. Okay, 5 years after, 5. A is question mark. Okay, do we understand this? How to assign numbers? Okay, so we always write the formula, assign the letter, and then substitute all these numbers into the formula. So A is P times 1 plus 0.06 over 12 to the power 12 times 5, which is 60. Okay, let's wait. Leslie, you have a number? You're still typing? Okay, I'll wait for you.
I have a number if needed.
Okay, Caitlin, do you have a number? Leslie, let me see. Leslie, I know you press numbers. What do you have?
I have 10116.37614.
14. This is what Leslie have. Caitlin, same number.
I have 39,812.92.
92. Okay, that's a huge difference. It's a 10,000 compared to 39,000. That's a huge differences.
I'll say I got the first one.
Kayla has the first one. Okay,
I have the first one too.
get the first one too.
I also have the first number.
Okay, so it's like a 4 of us have a first number. Let's see. Caitlin, did you have a right number to it, or what's going on in here? It's 39,000. Caitlin, you fix it? You're on mute.
Yeah, I didn't, I didn't multiply the 12 times 5 before I wrote it out.
Yeah, if you want to write it out, this is the thing. Okay, so Caitlin, you just did you tell me 12 times 5, right? That's what you did, right? If you want to write it out this way, you put extra parentheses, that works. Okay, that works. So some of us don't want to compute that exponent to 60 on top of it. That's fine as long as you put the parentheses. So you have power and then parentheses and multiply. That's okay to do it. So if you put the parentheses, then it works. Okay. Egan, you have any question?
To get that number 60, you always multiply the rate and the
Yes.
number
No, n times t.
n times t.
Yes, n times t, not the rate. N times t. It's nt.
Oh, I'm sorry. All right.
Okay, n times t, not the rate. All right, so we have here, okay, and then rewrite it. So this is $10,116.38. This will be my balance after 5 years. Are we okay with this? Okay, then let me go to next one. All right, now if we want to find the present value, so we know, okay, we know A equal to, okay, we know A equal to P times 1 plus R over N to the power NT, okay? I want to divide this whole thing to the both side, means P equal to A over 1 plus R over N to the power NT, okay? So we have same thing, I just rewrite it into different forms. So here is one formula, here's another formula. But why we write it in two different formulas here? If, okay, here is the tip. If the question is to find the future value, this is the better formula, A equal to. If the question is to find the present value, meaning how much we have to deposit now to get certain amount, you know what I mean? Then we use this formula. If P is question, P equal to. If A is question, A equal to. Do you see the difference? Okay, if P is question and A is question. Now I want to go back to this this problem here. Okay, problem 27. I want to go back to this problem here. 27 right here. Okay. So you deposit. So here's one thing. Let's just go over one more thing. You deposit 7,500. Okay, let's think about the standard. I mean, the common sense. Okay, without looking at the math formula. You deposit 7,500 5 years after. Your account balance is $10,116. How much interest you earned? Okay, that's my next question. How much interest you earned? Interest earned. This is 5 years after. This is the beginning amount. Your interest is simply your future value minus your present value. Okay. 26. Is it 26? 26, 16, 38. Is it right? Fix me if I'm not correct. That's a future value and interest. So I equal to future value minus principal. This is the interest that you earned, okay? So in compound interest, interest is I equal to A minus P. Future value minus present value. Do you understand this? Future value minus present value. So let's have an example. Okay, let's have an example. I want to move this to, let's see. Let's have a example right here. Okay, so let's try. Okay, so there's lots of stuff here. So yes, I want to go over more examples here. All right, try 15. Let's understand this. Okay, you deposit $1,000 in a bank, the rate of 2.95%. The interest is compounded quarterly. Here is a magic word, compounded quarterly. How much money will you have after 10 years? And find the interest. So let me give you a formula. A equal to P times 1 plus R over N to the power NT. Okay, this is a compound interest formula. I give you a few minutes. Go ahead and solve yourself and see how much you understand how to use the formula. Okay, so let's assign those the letters. So parent, P, A, R, N, T, parent. Okay, let's see. Hey, Teddy, what do you put P equal to?
$1,000.
Very good. P equal to $1,000. A is a question mark. R. Let's see. R is, Egan, what's R?
2.95%.
Okay, so convert to the decimal, which is
0.294.
0.0295, okay? You have to move two decimals, right? 0.0295 and equal to, okay, so here is something we have to be careful. Alexa, what's n equal to?
4.
4 quarterly. T, how many years? Caitlin?
10.
10, okay. Let's put A equal to 1,000, 1 plus 0.0295 over 4. Combine this together, which is a 40. Put that into exponent 40. Another Caitlin, do you have a number?
Yeah, I've got 1,341.67.
67, okay. Do we all agree with this? 1341.67. So we are looking for interest, which is A minus P. That is, okay. Dorothy, do you have a number for that?
Give me 1 second. I'm gonna do it in 2 seconds.
Mhm.
Uh, 341.67.67.
0.67, very good. So $341.67. This is amount of interest we earned last 10 years. All right, are we okay with this? Okay, what's the difficult part of this type of a problem here? What's the most difficult part? Are we okay how to assign those numbers into the letters? We good? This is the most difficult part. Agree? This is most difficult part. It's because your calculator is a functioning, then okay. Otherwise, everything else is a little bit of a trouble. Agree? So that's the problem. All right, I want you to do a couple more examples and then I move to the next topic. Okay, that's number 16, 17. Next page. Okay, 16 and 17. Make it big here. 16 and 17. Put it on the top of this. Okay. 16, 17. Okay. Page 34, 16 and the 17. Okay, 16 and the 17. I want you to look at this. Problem 16, problem 17, page 34. Okay, again, I give you a few minutes. Go ahead and try. Okay, go ahead and try. Okay, so let's go over this together. So problem 16, we're comparing two different accounts, one with 7.55% compounded quarterly, another is a 7.6% compounded semi-annually. So it looks like a 7.55% is a lower percentage rate than 7.6%, but let's see how much this quarterly and the semi-annually affect to this account. So without knowing this quarterly or semi-annually, more likely we picked 7.6%, okay? But is this always true? Let's check it, okay? So I make it into 2. All right, so we have, okay, there are a couple of things we have to do. A equal to P times 1 plus R over N to the power NT. That's the formula. Okay, let's look at the quarterly account here, semi-annually account in here. Okay, so P, A, R, N, T. Okay, so quarterly account. Let's assign those letters, P, A, R, N, T. Let's assign those letters. Alexa, can you assign those letters? Okay, all letters. Alexa, can you turn your webcam on it? Is the camera working for you? That's good. Okay, Alexa, tell me what are those letters to the numbers?
I was muted, sorry. For P, I did 10,000.
Okay,
For R, I did 0.755.
0.0755. Okay.
For N, I did 4.
Mhm.
And then for T is 5.
Very good. So we have good assigned numbers to the letters. So A equal to 10,000, 1 plus 0.0755 over 4 to the power, combine these together, 20. Okay, so we have this. Alexa had a correct formula and correct number. We need to find this number. Okay, let's see. Adam, do you have a number for that?
I have 1,400. Wait, 14,535.1.
Like that, 14,535.10. Okay, we all agree with this? Okay,
Yes.
let's move to semi-annually. So we have a P, A, R, N, T. Okay, I'm going to do the same thing. Let's see, Dorothy, do you want to try? What are these numbers assigned the letters?
Yeah, so I got P as a question mark.
Still P is a 10,000, okay?
Okay.
Okay.
Oh, I was doing the next. Oh, I did 17. I didn't do the. Wait, yes, I did. Yes, I did.
There are two parts. You just-
Yeah, sorry.
That's okay.
And then I did A is the question mark. R is 0.0760, I think, right?
Mhm,
Or just 0.76.
mhm. Okay. Okay.
N is 2, T is 5.
Okay, 2 is a 5. Very good. Okay, semi-annually, N equal to 2. So A equal to 10,000, 1 plus 0.076 over 2 to the power 2 times 5 is 10. And then we have a number. All right, Michael, do you have a number for that?
Where did the 2 come from?
It's because a semi-annually you paid twice a year. Okay. Michael, you're on mute. Leslie, you cannot hear me? Are you guys hear me okay? Leslie said she can't hear me. Yeah, okay. All right, so we need a number for this. Connor, do you have a number?
No, I don't have a number yet. I'm still plugging it in.
To plug it in. Michael, are you done? Can you share your answer? You're on mute. You're on mute, Michael. Make it unmute yourself.
I don't think his mic's working.
Okay. All right, so let's, who else can do it? Let me see. Because Mike say something I can't hear.
I have it.
You have it? Okay.
Yeah.
Okay, tell me what it is.
14,520.23.
20.23.
Yeah.
All right, now let's look at these two accounts. So one is a 7.55% compounded quarterly. It's a 7.6% semi-annually. Without knowing this knowledge here, we always pick 7.6%. Looks like, oh, 7.6%, I think it's better. I take this account. But you see that end up account balance, this account has a more value than that account. It looks like 7.55% is a less percentage, but it's because of the compounded quarterly. You get often interest, so you end up pay extra $15 more. You know what I mean? So which account is better? This account is better. So why is that? It's because you get interest often, you get interest more, right? Because it's a compound interest is interest on interest, interest on interest. You know what I mean? So we get this one. All right. So when you compare two accounts, I mean, nothing wrong with this computation. I mean, we can do it. Okay, we can do it, but it's a little bit of complicated, right? So we want to compare yield. So I want to cover one more step from here. Okay, I want to compare one more step. So let me erase this. Nothing wrong with this, okay? Because I need a space. You can use okay. Nothing wrong with this. This is all same thing. I want to compare instead of having this. Okay, I want to compare yield. Okay, yield, and we usually denote it as APY, annual percentage yield. Okay, annual percentage yield. So what does yield work for? Yield convert compound interest to simple interest. That's what it is. Okay, so yield is always a little bit higher percentage. So when you go to bank, they give you two columns of each account. One is APR, the rate, and the other is APY, the yield. You always look at the yield. Okay, so better, higher yield, better return. So yield formula, y equal to exact same thing that you have 1 plus r over n. Forget about t, so power n minus 1. That's yield. Okay, again, these formulas will be provided, will be given. So you don't have to memorize the formula. Make sure you know how to use it, when to use it, okay? So based on that, I want to substitute for first account, y equal to 1 plus 0.0755 over 4 to the power 4 minus 1. Okay, I want you to compute this now. Open parentheses, 1 plus 0.0755 over 4, close parentheses to the power 4 minus 1. You should have 0.0776646 and so on. Convert to percent, 7.766%. That's a yield. Okay, the other account, y equal to 1 plus 0.076 over 2 to the power 2 minus 1. And I give you a minute, go ahead and find the number. Okay, Kyle, can you share your number with us? Is your microphone doesn't work? Okay, Wyatt, do you have a number? You don't have number? All right. Olivia, do you have a number?
No, I don't. I'm still doing it right now.
Okay. Aaron, do you have a number? I'm waiting.
No, I don't. I'm sorry.
Okay. Jason, anyone?
I'm still plugging them in.
Still plug it in. All right.
I got 1.08.
1.08. It has to be decimal. It's 0.0 something. Adam.
I got 0.0774444.
444 like that. Adam, do you have some number? Or
Oh, I didn't subtract 1.
yeah, you subtract 1. You subtract 1. So this is a 7.74%. Do you see these two numbers here? So yield for first account, yield for the second account. As you see, yield for first account is a higher number. So clearly this account is better. Do you understand this clearly? You see that these two numbers? This account is better. What does that mean? That means when you compare two accounts, okay, higher yield has better return. So most likely, if you are comparing accounts, yield is the best way to comparing accounts. Okay, yield is best way to comparing accounts. It's called annual percentage yield. Okay, let's move to number 17. All right, let's move to number 17. How much money should be deposited today, okay, to get 15,000 in 10 years? All right, so how much money should be deposited today? P equal to A over 1 plus R over N to the power NT. Remember, if P is question, P equal to. If A is question, A equal to. How do I know it's P equal to? Because we are looking for present value, how much we have to deposit now. Parent P, A, R, N, T. Let's assign those. Okay, let's assign this. Okay, Connor, can you give us those numbers that we need to assign? So P is a question mark. Okay. A equal to?
A is 15,000. And then N for T10 and R 0.005.
0.05, okay. N equal to?
4.
4. Very good. So we substitute. So let's put this into the formula. 15,000 all over 1 plus 0.05 over 4 together 40 power 40. So it's exact same thing. You use your calculator, you type it 15,000 divided by open parentheses 1 plus 0.05 divided by 4 close parentheses to the power 40 as it's written. Okay, and you should have a number. Caitlin is she's.
I got 9,126.20.
Okay, let's see. Do we all have the same number? $9,126.20 now to get 15,000 in 10 years.